We're going to look at population standard deviation. So when we look at a set of data, standard deviation is a key measurement to look at to really help us understand what's going on with the data. So to just give you an idea of how to wrap your head around what's going on here, let's say 5 students take a test and let's just make this really kind of extreme. Let's say the first set of kids get 80, 80, 80, 80, and 80. This is very unlikely, but let's just say everybody got an 80, right? So very clearly the average score is an 80%. Okay, but then you have another set of kids that take the test and one kid gets an 80, but another gets 100, another kid gets a 60, and another kid gets 100, and another kid gets a 60. Okay, now we could calculate this. If you add all those up and you divide by the number of kids, which is 5, the average is still 80. So if somebody told you, oh, like the class average was an 80, okay, that's the average for both of these red and green ones, but the red one, all of them got an 80, and that average really tells you a lot. Whereas here, yeah, the average is an 80, but the test scores were pretty far spread around 80. There's a couple hundreds and a couple 60s, so some kids did extremely well, some didn't. And so this measure of how spread data is this standard deviation. In this red data, this would have a super small standard deviation. Actually, the standard deviation would be 0, but smaller standard deviation means all the data is really, really close to the average. Okay, and then over here, where the average is still 80, this would have a larger standard deviation. So in general, a standard deviation is how far spread data is about the mean, which is a fancy way of saying the average. So how far spread the data is, right? The more spread there is, the larger standard deviation. The less spread, the smaller standard deviation. So I'm going to show you how you can make the calculation. It's not that hard, especially with just a few numbers. So it says the ages and years of 5 doctors at a local clinic are right here. So here's their 5 ages. Assuming that these ages constitute the entire population, find the standard deviation for the population, round to at least 2 decimal places. Okay, so the first thing that we have to do is calculate the mean, which is basically the average. Okay, in statistics we use this Greek symbol mu to be the mean symbol. So to do that, it's just add them all up. So we have to do 49 plus 43 plus another 43 plus a 54 plus a 41. Now these ages are all pretty close, to be honest with you, so I have a feeling the standard deviation is going to be pretty small. And we're going to divide that by 1, 2, 3, 4, the 5 doctors that there are. So let's see if we can calculate this. Let's do 49 plus 43 plus 43 plus a 54 plus a 41. I get 230, and then I'll have to divide that by 5, and I get 46. So the average mu is 46 years old. Now the second thing that we're going to do is square the differences between each of the ages. So this is going to be called the variance, which is going to be denoted by the symbol sigma. This is the Greek letter sigma squared. So what I'm going to do is I'm going to take each data value and subtract it from the mean. So it's going to be 49 minus 46, and then I'm going to square that difference so that the difference, if it's negative, will become positive, And if it's positive, it just stays positive. Then I have to do that for all the data. So then I'm going to add the difference 43 minus 46 squared plus, then I got to do another 43 minus the average 46 squared plus, then I have to do 54 minus the average 46 squared plus, then I got to do 41 minus the average 46 squared. Then I have to divide that by the total number of data points, which again is 5. So let's see if we can calculate that. So actually it might even be easier to do this by hand. I'm going to go out on a limb here. So 49 minus 46, that's just a difference of 3 squared. So that's 3 squared, that would be a 9, plus 43 minus 46, that's negative 3, but when I square it, it's a 9, plus another 43 minus 46, that would be negative 3 squared, that would be a 9 again. Now 54 minus 46, that's a difference of 8, and when I square 8, that is 64, and then 41 minus 46, that's a difference of negative 5. When I square it, it'll be positive 25, and I have to divide all that by 5. So I'm going to get 9 plus 9 plus 9 plus 64 plus 25. That's 116. So it's 116 over 5. And then my last job, this is the variance. So this is sigma squared. So variance is just the square of the standard deviation. So the standard deviation, the last step, is to square root that and get the standard deviation, which is just sigma. And if you square root that, so square root 116 over 5, I get 4.82. I think we have to round to 2 decimal places. So basically you have to find the average, right? Find your average, take each data value, subtract it from the average, and square it, which is what I did here. Divide that by the number of terms, that gives you the variance, then square root it, and you have your standard deviation. And then in following topics, we'll talk more about what you can do with that standard deviation. Thanks for watching.